Alright, in this video, we're gonna study rational expressions. So here is a definition. A rational expression is a ratio of two polynomials. In other words, a rational expression is a fraction whose numerator and denominator are both polynomials. Here we have some examples. So here, these four things, they are all rational expressions. In the first example, the numerator and the denominator, they are both monomials. And here, the numerator and denominator, they are both polynomials. And in this example, the numerator is a trinomial, and the denominator is a binomial. In the last example, the numerator is a binomial, and the denominator is a polynomial. Another important definition is equivalent rational expressions. We say if two rational expressions are equivalent, that means if you pick up a random number and when you substitute that random number for x into both rational expression, if you get the same result, that means the two rational expressions are equivalent. Otherwise, they are not equivalent. So here, let me show you these two groups of rational expressions. The first two rational expressions, they are equivalent, so they are equal. And the second two are not equal, they are not equivalent. Let me show you why. Let's say if I pick up a random number, say x equals 0, and when I plug in the 0 for x into both expressions, here I will have 0 squared minus 9 over 0 squared plus 6 times 0 minus 27. So this gives me minus 9 over minus 27. So this is positive 1/3, right? And if I plug in 0 into this expression, I have a 0 plus 3 over 0 plus 9, which still be 1/3. And you will see this is true no matter which random number you pick up. Say if I pick up 1, okay, and when x equals 1, this expression is 1 squared minus 9 over 1 squared plus 6 times 1 minus 27. So this is negative 8 over 7 minus 21. So this is negative 8 over negative 20. So it's 8 over 20. And if I plug in 1 into this expression, I will get 1 plus 3 over 1 plus 9, which is 4 over 10. Now, 4 over 10 is equal to 8 over 20, right? Because if you divide by 2 on both numerator and denominator, you will get 4 over 10. So these two are equivalent. And for these two, you see they are not equivalent. For example, if I pick up 0, and no, I cannot do 0 because this side will be undefined. Let's see, if I pick up 1 and plug in into both expressions. So when x equals 1, this side I will have 1 squared plus 3 plus 1 over 1 squared plus 5. So this equals 5 over 6, right? And if I plug in 1 into this expression, I have 3 times 1 plus 1 over 5 times 1. So this gives me 4 over 5, right? So that's why these two rational expressions are not equivalent.